All right, we continue comparing the mean of two populations, and we were testing claim about that. The examples I did before, we chose two samples that were independent. So check those videos so you know how you do those scenarios. But now what we're going to do is we're going to work with two samples that are dependent. And when that happens, you're going to follow these steps, okay? So let's read this problem here. It says a shoe manufacturer claims that the athletes can increase their vertical jump heights using the manufacturer's training shoes. The vertical jump heights of 8 randomly selected athletes are measured. After the athletes have used the training shoes for 8 months, the vertical jump heights are measured again. The vertical jump heights in inches for each athlete are shown in the table below. Assuming the vertical jump heights are normally distributed, is there enough evidence to support the manufacturer's claim at alpha equal 0.10? So we're going to follow these steps when the samples are dependent. Okay, in a moment I'm going to explain to you what do I mean dependent samples. So let's start with step number 1. Okay, we need to make sure the samples are random. And in the second sentence here, that's what's stated. They chose 8 randomly selected athletes. So yes, the samples are random. The next requirement I need to check is that the samples are dependent. And here in this word problem, I'm comparing the vertical jump heights of 8 athletes before and after using a training shoe. And when that happens, that I'm doing a comparison with the same group of people and comparing something about them before and after, we call that a dependent sample. So yes, it met this requirement. Let's go to the next requirement that it asked me in step 1. Check that the populations are normally distributed. And if you check the last sentence of this problem, it says that the jump heights are normally distributed. So we met all the requirements of step 1, so we can proceed. Now we go in step number 2, okay, and that's when we're going to write the claim mathematically. The claim was stated in the first sentence. A shoe manufacturer claims that the athletes can increase their vertical jump heights using the manufacturer's training shoes. So I'm going to underline that because that is my claim. However, I need to write that claim mathematically. How do I know there was an increase in the vertical jump heights? Well, because there's going to be a difference between the before and after. So imagine I take all the athletes and I measure their heights before and after. And after I measure their heights, I want to find if there's a difference between before and after. Then I take those differences and I'm going to do a mean of the differences. That's why that claim that I underline in words, we're going to write it like this. The mean of the differences, because I'm interested in increase, is greater than 0. That's how we say increase. If it was decrease, I would have used less than 0. And if it was no difference, then I will have say equal to 0. Okay, and don't forget that after you write the claim mathematically, from words into math, in parentheses put the word claim. Okay, every claim has a counterclaim, so let's state the counterclaim of this. Okay, that mu d is greater than 0. It will be mu d, the opposite of being greater than is to be less than or equal than 0. However, in our textbook and in my stat lab, we don't use less than or equal. We always use equal. It doesn't make much difference, so I'm just going to write it like it's done in my stat lab. After I have the claim and the counterclaim, my next thing I need to do is label the claim as HO and HA. The claim that has the equal is HO. The claim that doesn't have the equal is H1. Okay. Look, we did step number 2. Now we go in step 3. What is step 3? We need to find alpha, the level of significance. Okay. And it's all the way at the end. You can see it right there. Alpha is 0.10. There we go. We did that. Step 4 now. Okay, we're gonna find the degrees of freedom. This is the formula we're gonna use to find the degrees of freedom. So step 4, I'm gonna type instead of write it. So we're gonna have here df, degrees of freedom, equal n. Who's my n? How many athletes we compare their vertical jump heights before and after? 8. Okay, 8 minus 1, because that's what the formula says. So our degrees of freedom is 7. And we did step number 4. Now we're going step 5, which basically I'm going to draw this bell-shaped curve. And I'm going to shade a tail. That's basically what I'm doing. Okay, now I shade one tail or two tails. Who always decide that? That's decided by H1. And H1, I have a greater than symbol. In other words, an arrow pointing to the right. That means I'm shading the right tail. That's what I did here. And that's step number 5. Step number 6. This is the part you're going to have to use Excel. You do it by hand, you're going to work a lot. I need to find two things. I need to find D bar. And what does D bar means? The average of all the differences between the vertical jumps before and after. Here's the formula. I just need to take all the D's, add them up, and divide it by how many I have. Okay, and how do I do that? In Excel. Okay, so this Excel file, you're gonna have it available. Of course, it's gonna be empty. Let me delete this. It's gonna be looking like this. All right, you just need to put the data in the green column. I'm sorry, look at me, the green columns, the gray columns, like I did right now, and automatically Excel will do the computation. Now look what it says here, the sum of D. There's a column called D, and these numbers came from subtracting the before minus the after. That's how I got all of these numbers. And after I did it to every row here, I add them all up, and look how much I got, negative 14. So that's the sum of D. Okay, so that will be negative 14. See, I'm just plugging in the formula. Sum of D. Now, who's my N? How many athletes participated? 8. Let's use my calculator. So negative 14 divided by 8. You can see I got negative 1.75. That's my bar D. Now there's something else you need to find in step number 6. SD. What is SD? The standard deviation of the differences between before and after. How do you find that? You can see there's two formulas here. You can use this one or you can use that one. I'm going to use this one here. For me, it's much easier to do. Okay, so I'm just going to put the square root, see, because that's what it says there. Now look what it says here, the sum of D squared. Where do you get that? Again, in Excel. Okay, so I need a column called D squared. Look, it's right there. How did I get that column? Because I took all of these numbers in D column and I square it. And I got all of those numbers. And then because I want the sum of them, I'm going to add all of these. That's what I got, 56. That's what I'm going to put here, 56 minus. Now I have a fraction here. Okay? And look what it says here, the sum of D squared. Now where do you get the sum of D? We did in Excel. Okay, this negative 14 is the sum of D. Okay, this minus 14, we got it from adding all of these numbers here. That's the sum of D. So what I'm going to do, negative 14, that's my sum of D. Now what are you going to do with that? You're going to square that. Hey, that's what I'm doing. And then whatever answer you get, you're going to divide it by n, which is 8. You can see I'm plugging in the top here of the formula. Then we have this long fraction bar. And on the bottom, I have n minus 1. So n is 8 minus 1. Now, I just plug in the formula. Once you plug in, just use your calculator. However, I'm going to use decimals calculator because I can type all of this in here. So I'm going to put the square root, then the fraction, then on the top 56 minus, then I have another fraction. On the top, I have a parenthesis, negative 14, close the parentheses. I had to square that. Everything over 8. And then on the bottom of the long fraction bar, I had to type a minus 1. And you can see who's my SD. My SD is, let me write it here on the side, is, where did my calculator go? I think usually you're going to use 2 decimal places. Always read the instructions to find out how many decimal places they wanted. I'm going to use 2, so 2.12. And I did step number 6 using Excel. So again, this Excel file, you're going to have it available in my lecture notes, but it's going to be empty. It's going to look like this. You just need to type the data in the gray columns like I did, and automatically all of these columns are filled in all of these boxes. All right, good. Let's go step number 7 now. What is step number 7? Oh, they asked me to find the test statistic. And how do you find the test statistic? Here is the formula. So T equal, look what the formula says, D bar. Oh, we got that already in step 6. Negative 1.75. Subtract. Who are we going to subtract? Mu D. Oh, mu D, look, you can see it right here. It comes from the claim. Mu D is 0. Oh, so put 0 there. Then over SD. SD we got in step 6, so 2.12. Now SD has to be divided by, you can see it there, by the square root of n. Who's my n? 8. And again, I'm going to do this in decimals. Okay, so let me clean this up and put it there. So I have a fraction, negative 1.75, take away 0, over, I have another fraction, 2.12 over the square root of 8. You can see how much is going to be your T value. T and Z scores are always 2 decimal places, so this will be negative 2.33. I just want to confirm I did this correctly, and yes. And I did step 6 already. I did step 7. Now we're going to do step 8. And what is step 8? Step 8 is we're going to find the p-value. How much is p? Okay, that's what I'm going to do. How do you find p? Well, look at the formula in step 7. It's a T equal. That means you're using the T calculator. Don't use this one. This is for Z. We're going to use the T calculator. Okay, so I need to fill in these 2 boxes. My degrees of freedom, we did that. That was step number 4, which is 7. Then the next box is my T value. That's what we did in step number 7. That's negative 2.33. And click calculate. You're going to get 3 answers. Check, watch. There's your 3 answers. Which one is going to be? It depends on your picture. You can see I drew a bell-shaped curve with the right tail shaded. So it's going to be the first one right here. This one here. Okay. Usually the p-value is going to be 3 decimal places. So 0.974. That's my p-value. 0.974. Now we're going to do step 9. And that step 9 is right here. Okay. And we're going to make the decision. How do you make the decision? You compare the p-value against alpha. That's basically what you're doing. What's my p-value? We just found it in step 8 is 0.974. How much is my alpha? You can see in step 3, that's 0.10. From left to right, the p-value is bigger or smaller than alpha? It's bigger. And what happened when the p-value is bigger? See, looking at this chart right here. Right there. When the p-value is bigger than alpha, we say fail to reject HO. Okay, and that is my step 9. We're going to the last step, the interpretation. Okay, step 10. How do you make the interpretation? Well, you're using this chart here. And you need to first choose the decision. That's what we did in step 9. We said fail to reject. So it's the second row here. And I need to choose, I need to find out where's the original claim. That is in step 2. Wherever you put the parentheses, that's the original claim. And I put in H1, which is the same thing as HA. So I'm in the second row and last column. Look for the intersection. And you're going to see that it says there is not enough evidence to support the claim. That's what I'm going to put here. Not enough evidence to support the claim. And what claim that the training shoes help increase the vertical jump heights of the athletes. Okay, I hope this makes sense.